Hello, everybody. Today we are studying percents, ratios, and proportions. Let's begin with the concept of percent. Okay. Percents actually are very common in most GMAT problems. And there are two methods to work with percents, especially with variables, which is a little bit more confusing than numbers. The first method would be divide two quantities when you want to find which percent represents one quantity with respect to another one. So you can do just the division of two quantities and multiply by 100 so that it doesn't just remain as a fraction, okay? A and B can be numbers or big expressions. Now, the other method is that you translate word by word, okay? In this case, you can translate word by word using this equivalence table, okay? For example, A is means equal. What percent? You can interpret this as a variable meaning a percentage, means W over 100, of means multiplication, and B is quantity B. So now all you do is focus on finding this variable W that represents the percent. Okay? Well then, the fractions are usually easier to operate than decimals, right? So they are really faster to operate or simplify. Even though decimals are, more quickly to write or to formulate, you have to be careful not to confuse the variable x of the percent with the decimal, okay? Sometimes when they tell you x% more, some people write just 1 plus x instead of, 1 plus x over 100, okay? So in the first case, actually, if x equals 20, you would be saying 21 instead of 1.2, okay? So be careful about this. Let's see an example here, okay? 30% of x is what percent of 120% of x? Well, I can do it using the method of multiplication, division and multiplication, which is identify your quantity A, identify your quantity B, and then do the division. A times B equals 30% of x divided by 120% of x, okay? And then you simplify this, simplify this, simplify this, and you just get 3/12, which equals 1/4. Then multiply by 100, and then this gives you 25. So that would be the answer. The method 2 is a direct translation of each word in the question. 30%, 30 over 100 is a percent as a fraction, times x equals what percent, that means W over 100, times 120% of x. So here the 100s can go away. 30 with 120, you just get 4 here. Okay, the x's can cancel, and you just isolate W. Okay, so you would be having 1 equals W times 4 over 100. You simplify again, and you have 25 here, and then W would be 25%. That's it. Okay, so let's talk about other percent problems in the GMAT. The calculation of the percent increase or decrease. How do you figure out, okay, the increase or decrease of a quantity if they tell you the percent change. They can give it to you as a number or as a variable. But what you need to do, every time they tell you to increase a quantity by X%, don't do this sum. Actually, this sum is equivalent to a product by this factor, which can be represented like this. So, for example, if they tell you that A needs to be increased in 15%, that means that you need to multiply A times 115 over 100, okay? This factor. If it was, for example, a decrease, if they tell me A must be decreased by 8%, then I will multiply A, right, by this factor, 100 minus A over 100. That is 92 over 100. That would be my decrease factor, right? So let's see an example. What's the result of increasing P by X%, then decreasing the result by Y%, and finally increasing the result by Z%? Well, if I need to increase something by X%, then I just need to multiply P times 100 plus X over 100. That would be the, oh, sorry, here it didn't show. Oh. Okay, over 100 times, we need a decrease factor for Y%. So it's 100 minus Y over 100, and increase again by Z% is multiplied by 100 plus Z over 100. This is much more simple than actually having to do this. Imagine that I add P, I add X% of P. And then if I need to decrease Y%, I need to subtract Y% of that same amount. And if then I need to increase by Z%, I would have to add Z% of the whole thing. And you see how humongous this is? It's super duper large. So never do this. Okay? Always use this method. Multiply by a decrease or increase percent factor. Okay? Let's continue with an example. Imagine they tell you if M is increased by 10% and then decreased by 20%, what's the total percent change? Okay, if I increase M by 10%, I multiply by 100 plus 10 over 100. That is this. And if then I need to decrease by 20%, I need to multiply by 100 minus 20 over 100. That is 80 over 100. I know that if I get a total percent change, I would get something like this, right? And multiply by a certain factor where, you know, this part would be a percent. So if I do here some simplification, okay, if I don't touch one of the 100 because I want to get a fraction like this, where the numerator indicates the percent to me. So I just simplify one of the denominators, not the two of them. Here 0, 0, and 0 go away. And that's it. I don't simplify any further the second 100 here. I just leave it untouched. Then 8 times 11 is 88. So actually this would be 8 times 88 over 100. Now, this would be the total percent change, but what does this factor represent? This is actually 100 minus 12 over 100, meaning that we have a decrease of 12%. So this is the answer, okay? Let's do the next example. If a store offers two options, either pay the price P, increased by an 18% tax, that means I multiply by this factor, and then receive a 10% discount, I multiply by this factor, versus pay the price P, receive a 10% discount, okay, so multiply by this, and then pay an 18% tax, that is, you can see the same two factors, but just in the reverse order. So actually they're equal, right? So which option results in lower total payment? None of them, because they are both the same. Let's do the second type of problem, which is when they ask you to find the percent change, that is the percent increase or decrease. They don't give you this value. So they give you two quantities, and what you need to do is to calculate what is the change between two quantities. So what you can do is do the difference, calculate the difference, divide by the original and multiply by 100 so that it doesn't remain as a fraction. You can take the positive difference always, knowing that you are going to increase or decrease. Sometimes the exercise, actually most times, they even tell you percent increase or percent decrease. So you know if it is about increase or decrease. For example, from 80 to 120, what is the percent increase? Okay, the difference between these two is 120 minus 80 divided by the original, which is 80. So we have 40 over 80 times 100. This goes away. 1/2 times 100 is 50%. Okay, what about the percent decrease from 120 to 80? Again, the decrease is the same, but now I divide by the original quantity. So it would be 40 divided by 120, which is 1/3 times 100. That is 33 1/3%. Okay, that's a way to calculate the percent increase or decrease between these two quantities. Example, what's the percent increase from 83 1/3 to 100? It's better to manipulate everything as fractions. So what is the first number? We can express as a pure fraction, like 3 times 83, it's 249, plus 1 would be 250 over 3. And 100 is just, 300 over 3. So now I can figure out the increase, which is 300 minus 250 over 3. And I divide by the original, which is 250 over 3. So I have 50 over 3 divided by 250 over 3. Go away, 5, 25, 1 over 5. I have 1 over 5, and then I multiply this by 100 to get the percent. So that is 20%. That's it. Okay, so it's just a matter to accommodate the quantities so that I can operate faster. Now let's talk about another topic, which is ratios and proportions. Okay, when we talk about ratios and proportions, we're talking about quotients. A ratio is a quotient of two quantities. So you can represent this in three ways: A over B, A to B, or A, D colon B. And what is a proportion? A proportion is the equation of two ratios. For example, A over B equals 2 over 3, or A is to B as 2 is to 3. When you work with proportions, you should always use a constant, okay, to operate separately the numerator and denominator of one of the ratios, especially for additions or subtractions. For example, here we can say this is same as 2k over 3k in such a way that A becomes 2k and B becomes 3k, right? So you can now add A plus B would be, for example, 5k. What would be B minus A would be k, and so on, okay? This is better than doing this. A equals 2/3 of B. Yes, don't do this. Always try to do this. Let's see an example. In a meeting, the number of men to the number of women is 2 to 3. If 6 more men and 4 more women were to join the meeting, the ratio of men to women would be 3 to 4. How many more women than men are in the meeting? Okay, don't forget that you can represent proportions, right? The number of men to the number of women, that is M, for example, to W. Oh, some problem here. Okay, M over W equals 2K to 3K. So they tell you if 6 more men and 4 more women were to join. So now the new number of men would be 2K plus 6. The new number of women would be 3K plus 4. And those new numbers would have a ratio of 3 to 4. So here, don't just put another K. If you want, you can put another constant like Q and Q. But this would be unnecessary because you cancel this and we can do a cross product to find the value of K. So from here, you have 2K plus 6 times 4, that is 8K plus 24. And this equals 3 times 3K plus 4, that is 9K plus 12. So from here, if we reduce, we have K equals 12. Now, how many more women than men are in the meeting? Yes, the difference between women and men, the actual women and men, is just 3K minus 2K, so that is 12. And that's the answer to the question. Okay, sometimes we're given multiple proportions. Okay, we have two methods to operate with multiple proportions. In the first method, you can just put the quantities in such a way that you can eliminate the variables that you don't want. For example, if they want me to find this, then I can say this, A times B times B over C equals A over C. So you can see that 1/3, the equivalent of A over B, allow me to, here, 1/3 times 2, 7, which is the equivalent of A over B and B over C equals A over C. So you just get 2 over 21. That would be the new proportion, right? What about the method of least common multiples? What we need to do is try to make equal the value of the repeated letters. For example, B here is 3, but here it's 2. We need to make the values alike because they usually, or they are supposed to represent the same value, right? For example, I can multiply here A over B, which is 1/3 times 2 times 2. So I have 2 over 6. And I can do the same with B over C, which is 2 over 7. I multiply by 3 over 3. I have 6 over 21. And now we use a common K for everything. So I just say, okay, if A equals 2K and C equals 21K, then A over C is 2K over 21K, and that is 2 over 21. And that's it. right? So have two methods to find what they ask you. Now, let's deal with this structure here, okay? In most proportions problems, you have the structure x times as many A as B. What does it mean? Well, this structure is very common and it's always expressed in the same way. So what does it mean really? Let's think about this. In a meeting, there are twice as many males as females. Does this mean that the number of men is double the number of females or vice versa? The number of females is double the number of men. What do you think? This might look like puzzling, but it's actually this. The males are double the number of females. That's what it means. It means the quantity that goes first, males, is always x times, this is x, the number that follows, okay? B. This is the interpretation of this structure and it should be automatic, okay? Now, when they give you x times as a fraction, then you can convert the problem into a proportion, okay? Let's see an example. In a box, there are 2/5 as many fiction books as non-fiction books. So I could say, okay, fiction books okay, here. Fiction books equals 2/5 as non-fiction books. But instead of dealing with the proportion in this way, I can write fiction books over non-fiction books equals 2/5 or 2k over 5k. Now they tell me there are 6 more non-fiction books than fiction books. That is to say, the difference between non-fiction books and fiction books is 6. So, but that is 5k minus 2k, which equals 3k, and thus k equals 2. Now, the question is, how many books are in the box? The total number of books would be 2k plus 5k, and that would be 14. So that's the answer. Okay?